Alright, welcome to lecture 25, the last lecture in this class. Congratulations, you've made it this far. Alright, so this is section 4.7, which is graphing the parabola using the 5-step method. Alright, so the graph of the quadratic equation, which we've been working with solving, remember. So for ax squared plus bx plus c equals 0, the graph of this is called a parabola. Okay, so not the parabola, the parabola. Alright, so here is an example of a parabola. So it's this sort of U-shaped item. Okay, we have the arrowheads going on forever or infinity, both sides. So there are some important details of the parabola. So the first detail we would have is a special point. Okay, and this special point is called the vertex. Now, what is special about this point? Well, it's the point right here, sort of where it cuts our graph in half. Notice it sort of has a mirror-like quality. If you just split our graph down the middle here, these sides, imagine if you folded it in half, they would just reflect each other. So the vertex is that point. Alright, so normally we would indicate it with v sub x for the x value and v sub y. Now, the vertex also has something else that's important about it. It's either going to be called the maximum point, think biggest point, max big, or it might be called the minimum. Okay, so a vertex would not be both the maximum and minimum, and I'll tell you why. So, for this example that we have here, if you look at our vertex here, is there a point that is below this vertex on our parabola? And the answer is no. This point here is the smallest possible point for our graph, or you would say it's the minimum point. Okay, so a parabola that opens facing upwards would have a minimum. Okay, so that's what would be important for our vertex. Now the other parabola we might look at, I'll just do a small sketch on the side here, is pointing down. Now this one, the vertex, would be up here. Now what's special about the vertex here is that this is called the maximum point. It's the highest point possible. All the other points on my parabola are all below this point. So, if you have a parabola opening down, you have a maximum point. Alright, so then the next thing we would have for a parabola are our intercepts. Okay, so for the intercepts, it is possible to have 1, 2, or 0 x-intercepts. And you might wonder, how is that possible? Well, I'll go ahead and show two side examples on how that's possible. Let me go ahead and use this space down here. So we have 2, 3. Alright, so I'll draw 3 different parabolas. So first one would be 1 intercept for the x-intercept, and that's boop, if we hit right here at the origin, just like this example over here on the left. The other one with just 2 intercepts might be something that dips below the x-axis, and we would cross at 2 points. So that would be 2 x-intercepts. So 1, 2. And then the example with no x-intercepts would be if our parabola is above the y-axis. So this would be no x-intercepts. Alright, so that's the interesting thing about our x-intercepts for our parabola. Now for the y-intercepts. You're only going to ever have 1. And you will always have at least 1. You always have 1 y-intercept. Alright. The last important detail of a parabola that we're going to be going over here, just of the 3, is something called the line of symmetry. Alright, so the line of symmetry is kind of like what I was talking about with the vertex. It's that imaginary line. It's not actually part of our graph, okay? But it's it's sort of an imaginary line that we could draw in. We would normally use a dotted line. And this line crosses straight through our vertex. And what it does is it creates that mirroring quality for us, or symmetry, between the two separate sides of our parabola, this side and this side. So, for example, if I knew a point that was let me change pens. Where's a different point? Here we go. If I knew a point that existed 1, 2, 3, 4 spaces away, I know, because of the fact that parabolas are symmetric, there must exist another point directly 4 units to the opposite side of the line of symmetry. Okay, so there will always exist a point the same space, same number of spaces away on either side of the line of symmetry. Okay, so that's the cool thing about the line of symmetry. So if I found this point here, I know that another point will exist directly across the line of symmetry, the same number of spaces away. Alright, so for example 1, we're going to find the formula for the x value of the vertex of a parabola. Alright, so let's take a little bit of context first. So if we have a random parabola, we're just going to use generic values here. All I know about this parabola is that there are two x values. Okay, I'm just going to call this x sub 1, and I'll call that one x sub 2. Okay, so let's see, x sub 1 and x sub 2. But I want to find the vertex right here. Now remember, what was the neat thing about the vertex? It had to do with that line of symmetry. It's directly in the middle. The distance in the middle is the same from this point to this point. So this point right here is the midpoint between x sub 1 and x sub 2. Now, if you remember from solving quadratic equations that the answers for x, remember x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so splitting up the positive and negative values, that would mean in our case x sub 1 equals the negative version and x sub 2 equals the positive version. Oops, that's the wrong positive. Alright, so these are my x sub 1 and x sub 2 values, and we said that the vertex, the x value, remember the v sub x, this is going to be the midpoint between x1 and x2. Now to calculate the midpoint, you just add up the two values and divide by 2. Alright, but remember, what were these two values? Well, x1 is, wrong one, this value, and x2 is this value. Okay, so I'm going to go ahead and add them up. And then divide by 2. Getting a little messy here. Okay, so that was my x sub 1 value. I'm going to go ahead and plug in my x sub 2 value. Now all of this was still divided by 2. Okay, so we're adding two fractions here in the top, so I'm going to go ahead, rewrite that, so because they're all over 2a, notice. So on the top we're going to have, let me bring down the v sub x value here. We have negative b minus b squared minus 4ac. So the negative b plus the negative b. That's going to be negative 2b. And then we have the negative b squared plus the positive b squared. So a negative and a positive, they cancel each other out. The whole square root values cancel each other out. That is awesome. So they're gone. So I don't even need to write out this whole right there. Okay, so that was still all over the 2a value right here. And then that is still over 2. Alright, so I'm going to do some simplification. We can go ahead and divide these 2's. And then we are left with v sub x equals negative b over a divided by 2. Let's go ahead and keep working over here to the side. So v sub x is going to equal negative b over a divided by 2. Let's go ahead and put that 2 over a 1 to work out the division of two fractions. And then v sub x equals negative b over a times 1 over 2. So v sub x is going to equal negative b over 2a. Alright, and we have now found the formula for finding the vertex of a parabola. Or at least the x value of the vertex of the parabola. So you might ask, well, how do we find the y value of the vertex? Well, for the y value of the vertex, all we do is we plug the answer we found in here into the function f of x, and we'll find our y value. And we'll go ahead and show that as we work on this next problem. Alright, so example 2. Graph the parabola y equals x squared plus 4x minus 5 using the 5-step method. Okay, so the 5-step method, so on your exam, because my math lab does not use the same exact format, please note that when you are graphing a parabola, the lecture notes will ask you to show the 5 steps, or at least some of the 5 steps, which the My Math Lab may not ask you to show. So please make sure to carefully read the notes and show the work for the values that I'm asking you to find. Alright, little side thing done there, let's get going. Alright, so step 1. Now, step 1 is going to be label the ABCs. Okay, so the a value is going to be the value in front of x squared, which is 1. Alright, the a value will also tell us if a parabola is opening upwards or downwards. And how will we know this? Well, if our a value is positive or greater than 0, we know our value is going to be upwards. Think of a happy face as positive. So if our a value is positive, it's a happy parabola. If your a value is negative, so less than 0, it's a sad parabola. Alright, since our value is positive, it's going to be an upward parabola. So please make sure to include this on your notes. This is an upward facing parabola. Alright, so b is going to be 4. And that's all we would write for b. Now c is going to be negative 5. And also, the good thing to note about c is that this is our y-intercept. Alright. If I plug 0 in for x, all these values leave, and we're just left with a negative 5. This is also my y-intercept. Once again, I write my y-intercept in the coordinate set notation. Alright, so let's go ahead and plot these points as we're going. So let's see. Y-intercept is 0, negative 5. Right there. Okay. Step 2. So the next step, we're going to find the vertex. Okay. For the vertex, v sub x, remember we have our formula, negative b over 2a. My b value was 4. And my a value is 1. That's going to be negative 4 over 2, which is going to equal negative 2. Alright, so how do we find our vertex, our v sub y value? Well, to find the y value, we're just going to go ahead and take our equation, because it says y equals x squared plus 4x minus 5. So let's go ahead and use that. So remember, for your y value, how to find it is always going to change, because you'll be given a different equation each time. Finding the x value will never change. This is the consistent formula. But finding the y value will depend on what equation you are given. Alright, so we're going to go ahead plugging in the x value. And we get v sub y equals 4 minus 8, so negative 4 minus 5. V sub y is going to equal negative 9. Alright, so I have my vertex value. Remember, it's a point, so please write your answer out as a point, just like you would with your intercepts. And let's see, our vertex is negative 2, 9. So negative 2, 9. Boop, right there. And I go ahead and label that with a V, and I'll go ahead and label this with 0, negative 5. Okay, so I have a question for you. Are we going to have x-intercepts or not? Well, I know my parabola opens upwards, and the vertex is going to be down here. So, will we have x-intercepts? The answer is yes. It'll have to pass through here. So we will have we will have x-intercepts, so we're going to go ahead and solve for those in the next step. Okay, so step 3. Intercept. So x-intercept. Okay, remember to find the x-intercept, you just set y to 0 and solve. So we're going to use our equation. My cat is near my microphone. Sorry, you might have heard her purr. Alright. Let's see. X-intercept, so we're going to set y to 0. And solve. So 0 equals x squared plus 4x minus 5. Let's go ahead and see if we can factor this to solve. Remember, this is a quadratic equation, which we practice solving. I'll go ahead and see if I can factor this. So I have x, let's see, plus 5, x minus 1. Alright, so then I get that x plus 5 equals 0, x minus 1 equals 0. Solving for x, I get x equals negative 5, and x equals 1. Alright, so we have y-intercept 1, 0, and the second one, negative 5, 0. Okay, I'll go ahead and box those. And let's graph those. Negative 5, 0, and 1, 0. And the fourth step. This is going to be finding the fifth point. Alright, so please make sure to always find 5 points for your parabola. Just like for your line, I would ask you to find 3 points for your parabola. We need to find 5 points. So we are missing a point. I see 1, 2, 3, 4. So step 4, we have 2 options. We can use the line of symmetry to find a matching point, and that normally only works if you have an oddball point that does not have the reflecting point. Aha, which would be this one. He doesn't have a point over here. So I could use a line of symmetry there. I'll just simplify that with line of symmetry. Or you could use a table of values. That's where you would pick a random x value and solve for y, which you could do. We practiced that before. I'm going to use a line of symmetry, however, to find my other points. I'm going to go ahead and draw in that imaginary line. And then I want to find the matching point for this guy. So to do that, my point is 1, 2 values away from the line. So I know there must exist a point exactly 1, 2 points away from the line of symmetry. So I'll go ahead and plot that point in. And this point is negative 4, negative 5. Alright, I have all 5 points, so I'm going to go ahead and... Ooh, that was kind of ugly. Draw in my parabola. Please note that there is a curve down here at the bottom. It's not a sharp point, it's a curve. Alrighty, so those are the 5 steps, because the graph is the 5th step. 5 steps for graphing a parabola. Alright, so let's go ahead and use the 5-step method to graph this next parabola y equals half x squared minus 4x plus 9. Alright, so first step, we're going to label our ABCs. Go ahead, pause the video, label these, and make sure to indicate whether the parabola opens up or down, and what the y-intercept is. Alright, so A value is half, B value is negative 4x, and C value is 9. So this is positive, so my parabola opens up, and then this is my y-intercept. Alright, so step 2, my vertex. I'll go ahead and also plot my y-intercept value first before I continue. 0, 9. Alright, so my vertex, we're going to use our vertex formula. V sub x equals negative b over 2a. That's going to equal negative 4 all over 2 times the a value, which is a half. Alright, so the 2's cancel each other out, and we're left with positive 4 over 1, which is going to be just 4. So my x value is 4. Let's go ahead and find my y value. How do I find my y value? Well, remember, that always is from our equation. So if you said y is going to equal a half times my x value, and inputting my v sub x value, multiplying that out by 4, and what do we get? V sub y equals 1 half times 16 minus 16 plus 9. So v sub y is going to equal a half times 16 is going to be 8 minus 16 plus 9. So 8 minus 16, that'll be negative 8 plus 9, which will be positive 1. So my v sub y value is positive 1. Alright, that means my vertex is 4, 1. 4, 1. Alright, so before I keep going though, to step 3. So let's see, step 3, my x-intercept. Now, I could go ahead and try and start to solve my equation, 0 equal to 1 half x squared minus 4x plus 9. But I'm going to pause and ask us a question here. Looking at the points I already have for my graph, so my y-intercept right here and my vertex right here, and knowing that my vertex opens upwards over here, I have a question for you. Are we actually going to have any x-intercepts? Because remember, my vertex is my lowest possible point. I can't go to any points lower than this. All I can do is go up. However, we have a problem. My x-intercept is down here. Will my parabola ever actually cross the x-axis? The answer is no. We won't actually have any x-intercepts. Alright, so the answer is going to be, for this problem, x-intercepts, none. And you could say, as your reasoning, vertex above axis, and parabola opens upwards. Alright, so we don't have any x-intercepts, but all we have are 2 points. Well, that's kind of hard. Remember, we need to have 5 points. How do we find 5 points? Well, remember, for step 4, I have 2 options. Line of symmetry and table of values. Well, I can use the line of symmetry once because I have my y-intercept here does not have its matching point over there. I'll go ahead and use that to find that matching point. So we have 1, 2, 3, 4. All right, which means I have 4 units to the right. 1, 2, 3, 4. There we go. Our third point, which is going to be, let's see, that's 8 and 9. So 8, 9. All right, we have 3 points. How am I going to find my last 2 points? I can't use the line of symmetry anymore. Let's use table of values. All right, so we have x and y. I'm going to go ahead and pick an x value to plug in and solve for y. Let's go ahead and pick x equal to 2. I'm picking this number because, remember, I'm planning on the fact that I'm going to have to be multiplying by a half, and I know 2 works well with that. So remember the equation for y was half x squared, and I picked x equal to 2, plus, or minus, sorry, minus 4 times my x value, which I picked to be 2, plus 9. All right, let's go ahead and simplify this. Half times 4 minus 8 plus 9. So that's going to equal 2 minus 8. 2 minus 8 plus 9, which is negative 6 plus 9, positive 3. All right, so we have the point 2, 3. Let's go ahead and plot that point, 2, 3. And then we can use a line of symmetry to get the other one. Positive 2, up 3. All right, I can use a line of symmetry to find the other point instead of having to do the table of values again. So I know this is 2 units over, so I can go ahead and find the exact matching unit on the other side, 2 units over. And the value for this is going to be, let's see, 6, 3. And there we go. We have our 5 points. Go ahead and fill in our parabola. Okay, so lastly we have our applications. Alright, so a farmer wants to build a rectangular garden against the back of his house. He plans to only fence in the 3 sides not touching the fence. He has 120 feet of fencing available. Alright, draw a diagram or picture to represent the problem. Okay, so let's go ahead and draw this as the top view of the house. And then we have, remember this is going to be a rectangular garden, so we have these 2 sides, and then the 2 sides over here are going to be the same length, and this one here will be the different length. Alright. Okay, that's a nice diagram. So for B, what would the dimensions of the garden be with one side attached to the house that makes the area of his rectangular garden as large as possible? Well, let's see. To find the area, I need length times width, because length times width is the formula for area, right? But I don't know what any of the length or widths are. I don't know what these values are over here. Well, I can go ahead and, let's see. I know that if this is x, the other one should be matching x as well. Those both should be the same number, right? Because they're the same sides. It's a rectangle. Okay, so let's call those x. But what would this value here be? Well, that's just going to be, because remember we have only 120 feet of fencing, so it's going to be 120 feet minus however much he used over here. So minus those 2x values. Alright, so 120 minus 2x. Alright, so we have our length and our width values. I'll go ahead and plug those into the equation. So it equals x, sorry, the length was 120. 120 minus 2x times x. Alright, so what we want to find now is the maximum or the largest dimensions. Okay, so the dimensions are the x values. And when we're talking about the largest, that's talking about maximum, right? Large would be max. So there should be a point in a parabola that makes you think of the word max or min. Okay, so that should be the vertex. That's going to be the largest point possible. Okay, so we want to solve for the vertex of our equation, because that will give me the maximum x value. So I want v sub x. Why? Because that'll give me my maximum x value. Okay, so how do we find v sub x? Well, v sub x is negative b over 2a. Where will I find b and a? From my equation over here on the left. So a equals 120x minus 2x squared. Let me go ahead and rewrite this. I get negative x squared plus 120. Now, if you wonder where this came from, remember, that's just distributing right up there. All right, so my a value is negative 2, and my b value is 120. All right, let's go ahead and plug these into the equation. And what do we get? We get negative 120 over 4. Negative 4. So negative 120 divided by negative 4 is going to be positive 30. So since my x value equals 30, okay, so this is going to be 30. And the other one was also x, so that'll also be 30. The question is, what is this value? Well, let's just go ahead and plug 30 into this equation. So I have 120. Let me just go ahead and do that on the side here. The length equaled 120 minus 2x. So that's going to equal 120 minus 2 times 30. Okay, so we're solving for the length here. 120 minus 60, so 60. All right, so the length is 60. Let's go ahead and write that down. The length is 60, and what unit was this? Feet. And the width were 30 feet, period. All right, so the last step, what is the maximum area? All right, well, the maximum area he could achieve with his 120 feet of fencing, well, the maximum area, we're just going to use the maximum dimensions. And the maximum dimensions were 60 and 30. Okay, so let's see. We had our house, the top view of the house, and then we had the fencing. And we know the fencing was 30, 30, and 60. And now we want the maximum area. Well, remember, we already know area equals length times width. And the length here is 30. Sorry, that's the width. The width is 30, and the length is 60. So area is going to equal 60 times 30, which is just going to be 1,800 square feet. So my answer is the maximum area is 1,800 square feet. Or you could write feet squared. All right. And remember, we found the maximum area by using the maximum dimensions. And we found the maximum dimensions by using the formula for the vertex. All right, so that is it for 4.7. Welcome to the end of Math 75X. Congratulations. Please email me if you have any questions.